Murray Shanahan is a professor of cognitive robotics at Imperial College London and a senior research scientist at DeepMind. He graduated from Imperial College with a first in computer science in 1984 and obtained his PhD from King's College in Cambridge in 1988. He's since worked in the fields of artificial intelligence, robotics, and cognitive science. He's published books such as Embodiment and the Inner Life and The Technological Singularity. His book Embodiment and the Inner Life was a significant influence on the film Ex Machina, for which he was a scientific advisor. Now, Professor Shanahan is a renowned researcher on sophisticated cognition and its implications for artificial intelligence. His work focuses on agents that are coupled to complex environments through sensory motor loops, such as robots and animals. He's also particularly interested in the relationship between cognition and consciousness, and has developed a strong understanding of the biological brain and cognitive architectures more generally. In addition, Professor Shanahan is interested in the dynamics of the brain, including metastability, dynamical complexity, and criticality, as well as the application of this understanding to machine learning. He's also fascinated by the concept of global workspace theory, as proposed by Bernard Baars. We'll be talking about that on the show today, which is based on a cognitive architecture comprising a set of parallel specialist processes and a global workspace. Professor Shanahan is committed to understanding the long-term implications of artificial intelligence, both its potential and its risks. His research has been published extensively, and he's a member of the External Advisory Board for the Cambridge Centre of the Study of Existential Risk, and also on the editorial boards of Connection Science and Neuroscience of Consciousness. Conscious Exotica. Professor Shanahan wrote an article called Conscious Exotica in 2016, where he invited us to explore the space of possible minds, a concept first proposed by philosopher Aaron Sloman in 1984. Now, this space is comprised of all the different forms of minds which could exist, from those of other animals such as chimpanzees, to those of life forms that could have evolved elsewhere in the universe, and indeed, those of artificial intelligences. Now, in order to describe the structure of this space, Shanahan proposes two dimensions: the capacity for consciousness and human likeness of the behavior. According to Shanahan, the space of possible minds must include forms of consciousness that are so alien that we wouldn't even recognize them. He rejects the dualistic idea that there's an impenetrable realm of the subjective experience. Remember, we were talking about Nagel's bat on the Chalmers show, insisting instead that nothing is hidden, metaphorically speaking, citing Wittgenstein actually. Now, Shanahan argues that while no artifacts exist today, which has anything even approaching human-like intelligence, the potential for variation in artificial intelligences far outstrips the potential for variation in naturally evolved intelligence. This means that the majority of the space of possible minds may be occupied by non-natural variants, such as the conscious exotica, of which Shanahan speaks. Now, ultimately, Shanahan's exploration of the space of possible minds invites us to consider the possibility for human-like minds, but also for those that are radically different and inscrutable. He concludes that, although we may never understand these alien forms of consciousness, we can still recognize them as part of the same reality as our own. So, Professor Shanahan has just dropped a brand new paper called Talking About Large Language Models, in which he discusses the capabilities and limitations of large language models. Now, in order to properly comprehend the capacities and boundaries of these models, we must first grasp the relationship between humans and these systems. Humans have evolved to survive in a common world and have cultivated a mutual understanding reflected in their ability to converse about convictions and other mental states. Conversely, AI systems lack this shared comprehension, so attributing beliefs to them should be done circumspectly. Now, prompt engineering is something that we've all become very familiar with. We've discussed it a lot on this show recently, and it's almost become a fact of the matter when it comes to these large language models. It involves exploiting prompt prefixes to adjust the language models to diverse tasks without needing any supplementary training, allowing for more effective communication between humans and machines. Nevertheless, lacking a more profound understanding of the system and its relationship to the external world, It's difficult to be certain whether the arguments produced by a large language model are genuine reasoning or simply mimicry. Large language models can be integrated into a variety of embodied systems even, such as robots or virtual avatars. However, this doesn't necessarily mean that these systems possess completely human-like language abilities. Even though the robot in the Seikan system is physically embodied and interacts with the real world, its language is still learned and used in a dramatically different manner than humans. So in summary, although Professor Shanahan concludes that large language models are formidable and versatile, they're fundamentally unlike humans, and we must be wary of ascribing human-like characteristics to these systems. We must find a way to communicate the nature of these systems without resorting to simple terms. This may necessitate an extended period of interaction and experimentation with the technology, but it's a fundamental step if we are to accurately portray the capabilities and limitations of large language models. So, anyway, without any further delay, I give you Professor Murray Shanahan.
Professor Shanahan, it's an absolute honour to have you on MLST. Tell me a little bit about your background.
My background? Well, I've been interested in artificial intelligence for as long as I can remember, since I was a child, really, and I was very much drawn to it by science fiction movies and books. And then I studied computer science right from when I was a teenager and got very much drawn into programming, was fascinated by programming. I really did my 10,000 hours of programming experience when I was quite young. Then I went on to do computer science at Imperial College, London. That was my degree. And then, still fascinated by artificial intelligence, I went on to Cambridge and did my PhD in AI in Cambridge, very much in the symbolic school then. And then I had a long affiliation with Imperial College, did my postdoc there, and still in symbolic AI. And then at some point I became a bit disillusioned with symbolic AI, and I kind of segued into studying the brain, which was the obvious example of actual general intelligence that we have. And I think it was a good 10 years on an excursion into neuroscience and computational neuroscience and that kind of thing, and then deep learning and deep reinforcement learning happened in the early 2010s, and AI started to get interesting again, and I got very much back into it that way, and I was particularly impressed by DeepMind's DQN, the system that learned to play Atari games from scratch, and I thought that was a fantastic step forward, and I really kind of went back to my roots and back to AI at that point.
Yeah, and I think we'll talk about DQN when we speak about your article on consciousness. But so having such a diverse, set of experiences in adjacent fields, how have they influenced each other?
Yeah, well, and one thing I didn't mention is that I've also had a long-standing interest in philosophy, and I very often think that what I am is a sort of weird kind of philosopher, really, and philosophical questions have had a great attraction for me. So I think there's a kind of, there's a sort of three-way interrelationship between artificial intelligence, neuroscience, and the other cognitive sciences, and philosophy. And I think they all kind of mutually inform each other, really. Yeah.
Fantastic. So you wrote a book called Embodiment and the Inner Life. What motivated you to write that book?
Yeah, so at that point, that book was published in 2010, and it was the culmination of a sort of long excursion into thinking about consciousness and about brains, which took place after I had moved away from symbolic AI, really. So I was thinking about the biological brain. In the back of my mind, I'd always been fascinated by these philosophical questions about consciousness. And then I went a bit kind of crazy and started, thinking about these things seriously. It became kind of my day job to think about neuroscience and about consciousness. And around about that time, the science of consciousness was taking off as a serious academic discipline with proper experimental paradigms. So that was really fascinating. And I got to know Bernie Bars. Bernie Bars is the person who originated global workspace theory. Global workspace theory being one of the leading contenders for a scientific theory of consciousness. And I was very drawn to global workspace theory, and partly because it was a computational sort of theory. It drew very heavily on computer science and computer architectures. There was a computer architecture at the center of the theory. So this kind of collection of interests, along with my philosophical interests, sort of all came together, and I wanted to put them all into a book where I express my kind of ideas about, first of all, from the philosophical side, very heavy influence of Wittgenstein about how we address these problems at all. Then lots of global workspace theory and a certain kind of global workspace architecture, how that might be realized in the brain, drawing also on the work of Stanislas Dehaene, who was working on what he called the global neuronal workspace idea, and putting all these things together into one big book.
Amazing. Well, we'll speak a lot about Wittgenstein when we speak about the language model paper and your consciousness paper, but two things that did trigger or prick my ears up: computationalism, which is quite interesting because some folks in the cognitive science arena, especially with the 4Es, like examples to escape from computationalism. And we did a show on Searle's Chinese room argument the other day. He's probably one of the most known people who do eschew computationalism. So what do you think about that?
Yeah, well, actually, so when I was talking about global workspace theory, I mentioned that it sort of comes out of a kind of computational architecture. But in fact, where I took it was very much moving away from that original presentation, which drew heavily on a quite an old-fashioned architectural perspective, sort of boxes and how they communicate with each other and so on. And I was much more interested in taking it in a direction which is very much more connectionist and drawing much more heavily on the underlying biology and neuroscience, which in fact is also a direction that Bernie Bars himself, had moved in, because the book that originally put forward his theory is from 1988. So it's that was the predominant way of thinking at the time, was this very computational cognitivist perspective.
Yeah.
So by 2010, when my book was published, I was very much more interested in a kind of more connectionist perspective on things, and so that's the way that it's portrayed, and in the book, the theory.
Fascinating. Because in this arena, some people cite Penrose and or the need for hypercomputation, because people talk about the Church-Turing hypothesis and this idea that the universe could be made of information, which is quite interesting. But do you believe that the world that we live in could be computationally represented and computed?
Well, I'm not sure that I have a belief on that particular one. I mean, Penrose's ideas about consciousness, of course, draw heavily on quantum mechanics, and he thinks that quantum effects are important for consciousness. But I mean, that's very much a tiny minority view within the people who study consciousness from a scientific standpoint, and so I don't really subscribe to that point of view, I have to say.
Well, I mean, coming at it from a slightly different angle, we spoke to Noam Chomsky recently, and I've just done some content on Nagel's bat, a couple of rationalists, and their big argument is about the subjective experience and the limits of our cognitive horizon, and the inability really for us to reduce things into a comprehensible framework of understanding. So how would you bring that in?
Yeah, well, gosh, I mean, we've launched right into some really big, difficult topics here, right?
Yeah.
So in my book, Embodiment in the Inner Life, which at the time I thought I'd really kind of like wrapped up the problem of consciousness, and but one of the big sort of outstanding things for me in one of the outstanding questions that I had not really answered, I felt in that book, is very much related to Nagel's question about bats. What is it like to be a bat? So, and it's to do with the idea that there's a sort of intuitive idea that maybe there can be very exotic entities, very exotic creatures who are completely unlike us, and yet somehow there's some kind of consciousness there that we could barely grasp its nature, and this is it's a sort of natural intuitive thought, and especially when we look at other animals like bats, and especially if we look at an animal that's a bit different from us, then we get hints that there's someone at home, as it were, and that there's consciousness there. I'm sure all of us believe that cats and dogs, and many other animals are conscious and are capable of suffering and have an awareness of the world that's like our awareness, and are aware of us and each other, and so that's I think that's I take that as almost axiomatic. That's just the way we treat those creatures. But then when we think about something like a bat, and it's very different from us, so the natural thought is that maybe what it's like is very, very different from what it's like for us, and it's a natural thought to express. And of course, Nagel takes that thought to suggest that there's something that is inaccessible to us, which is what is it like to be a bat is something we can never know, and this is a very un-Wittgensteinian thought, and I'm very much I'm very attracted to Wittgenstein's philosophy, but it's also a very natural thought that so it's a very un-Wittgensteinian thought, because Wittgenstein says, for example, nothing is hidden. So he's very and the whole private language remarks are all about sort of saying, well, this intuition that we have that there's this private realm of experience is actually it's just a philosophical trick of the mind to think that this sort of peculiar metaphysical realm exists of inaccessible subjective experience in others.
Yes.
And that's his whole thrust of his philosophy, or that that aspect of it, is to try and undermine that. So these two things are in tension, right? So there's this natural thought that bats, it must be like something to be a bat, but what is it like, and how could we ever know? And then there's the Wittgensteinian thought, which is actually very difficult to kind of really embrace, but it's that there's a sense in which nothing is really metaphysically hidden. It's only hidden, could be hidden empirically, because maybe we don't know enough, maybe we haven't hung around with bats often enough, or maybe we haven't examined their brains, but that's all empirical, right? So there's nothing metaphysically hidden, whereas Nagel's point is that there's something that's deeply, profoundly, philosophically, metaphysically hidden, which is the subjective. Now we can extend that. Shall I carry on? So, so I'm rambling now. So we can extend that thought about bats now, especially from the perspective of the sort of thing that I'm interested in, to, well, not just bats, but what about the whole space of possible minds, to use Aaron Sloman's very evocative phrase? What about extraterrestrials who are going to be, who surely there is extraterrestrial intelligence out there, and it's going to be very, very, very different to us. So, and then what about the things that we build? Maybe we can build things, an artificial intelligence of the future. Maybe we can build something that is also conscious. It's the kind of thing that's depicted in science fiction all the time. In science fiction, it's often depicted as very human-like, but there's no reason why it should be human-like at all. And so we can imagine these very, very exotic entities. And then the question is even bigger. There could be something that we won't even be able to recognize that there was even the possibility of consciousness, but maybe it's buried there inside this complex thing somehow. So that was the kind of question that fascinated me. And I wrote this paper called Conscious Exotica, which is all about trying to make that Wittgensteinian perspective encompass this possibility as well.
Yeah, and maybe we should talk about that before the language paper, just because it's what we're talking about now. But there's a few things you said there which were really interesting. So when Chomsky talks about ghosts in the machine, and he goes back to Galileo and Descartes, and actually it was Descartes who introduced this kind of mind-body dualism, which was kind of a move away from the previous desire to have a mechanistic understanding of the world that we live in. Humans want to understand, and actually so many things in the world eludes our understanding. And then that brings us on to David Chalmers coined the hard problem of consciousness, which I suppose is an extension of the mind-body problem. And it's, as you were saying, this little bit extra, right? So we think about, and I agree with Chalmers that intelligence and consciousness are likely entangled or would co-occur together, but he always said that there's function, dynamics and behavior, and then there's that little subjective thing on the top. And for Chalmers, consciousness, it's almost like, what's the cash value of it? He just thinks it's just something on top. It's not really requisite for anything else. And I believe it might be requisite for intentionality and agency, as Searle did. But what's your take?
Well, it's interesting because the whole way that you put that, and the whole way that people often talk about this thing, is you speak about consciousness. Like there's this thing, which, there's this singular thing, which maybe it's needed, maybe it isn't, maybe it's this, maybe it's that. But I think that whole way of talking is which is natural for us in many everyday situations. But when it comes to this kind of conversation, I think that whole way of talking is maybe not quite right, because we're thinking of consciousness as this, we're reifying it, turning it into this thing. Whereas I think maybe at that point we have to take a step back and we have to say, well, when we talk about when we use that word, conscious or consciousness, so we use it in all kinds of different ways in different contexts. And so when we talk about, we might talk about it in the context of an animal. We might say, well, the animal, this dog is aware of its environment. So this dog can see the bowl in front of it. It can see me. It can see the door. It can see the trees. It can see the squirrel. And it can smell. More likely to smell all of these things as well. So we use consciousness. We talk about consciousness in that sense, and we also talk about our self-consciousness. We talk about the fact that we're aware of our own thoughts, and we talk about our inner life, and we use consciousness to encompass that as well. We often use consciousness in the context scientifically of a distinction between conscious and unconscious processes, and that's a very interesting distinction, because when we're consciously aware of a stimulus as humans, then a whole lot of things come together. We're able to kind of like deal with novelty better. We're able to report it. We're able to remember things better. So whereas when we perhaps are unconsciously, or there's a kind of unconscious processing of a stimulus, then we still can respond to it behaviorally, but and it can have cueing effects and so on, but it doesn't have all those other things. So there's a kind of integrative function for consciousness there. And then on top of all of that, there is the capacity for suffering and joy that comes with. So often there's valence to consciousness, and so that's another thing. So all of these things, they come as a package in humans, but when we speak about edge cases, then these things come apart, and we need to speak about them separately, I think.
Fascinating. Well, I mean, there are two kind of minor digressions there. I mean, you were talking about these planes of consciousness, which is also very interesting, and maybe we could get into the integrated information theory or the global workspace theory, just for the audience, just to give them some context.
Yeah, sure. Or do you want me to say a few words about?
Oh, please,
them?
yeah.
Yeah. Okay. So there are a number of kind of candidates for a scientific theory of consciousness. And you just mentioned two of the leading ones, which are global workspace theory and integrated information theory. And so global workspace theory, so that's Bernie Bars's, was originated by Bernie Bars and has been developed by Stanislas Dehaene and colleagues. So the idea there is it does rest on this sort of architectural idea, which is that we think of the brain, the biological brain, as comprising a very large number of parallel processes. This is kind of a natural way to think of the brain. A large number of parallel processes, and the global workspace theory posits a particular way in which these processes interact and communicate with each other, and that is via this global workspace. And the idea there is that there are sort of two modes of processing that go on. So in one mode of processing, these parallel processes just do their own thing independently, and in the other mode of processing, they are working via this global workspace theory. So the idea is that you might think of them as depositing messages, if you like, in this global workspace, which are then broadcast out to all of the other processes. So there's this kind of, but I think thinking of it in terms of messages is not quite the right way of thinking of it. It's better to think in terms of kind of signaling and information and so on. But that's a sort of natural way to think of it. But so in that mode, these processes are sort of disseminating their influence to all the other processes, and that's the global kind of broadcast aspect of it. And that's when consciousness that's when information processing is conscious, according to global workspace theory,
Yeah.
as opposed to when it's all just local and the processes are doing their own thing. That's not that processing is not conscious. So there's so it's about teasing out this distinction between conscious information processing and unconscious information processing. Now, all of those terms, by the way, are deeply philosophically problematic, and to go in, to sort of do it properly, you have to kind of unpack them all very carefully, and that's what my book tries to do. But so essentially, it's about the essential idea, though, is to do with broadcast and dissemination of information throughout the brain, and going from like local processes and them having global influence, and that's what consciousness is all about, according to global workspace theory. Okay, so integrated information theory. So I think integrated information theory, which is Giulio Tononi's theory, which Giulio Tononi thinks is kind of incompatible in some ways with global workspace theory, but I don't think that's true. I think that there's a lot of synergy between the two theories, in fact. But that's because they come with integrated information theory has sort of two aspects to it. So according to Giulio Tononi, he really is trying to pin down a property which is almost like a physical property, which is identical with consciousness. So you can actually speak about the amount of consciousness in any system that you look at. Phi, it's phi. So the phi is a number. It's actually a number of how much consciousness is present in the system, like part of your brain or your whole brain, or you as a person, or a flock of bats, or whatever. So you can, or a toaster, so you can give a number to how much consciousness there is there, according to his theory. And it's a mathematical theory based on Shannon's information theory, but it's all about trying to see how much information is processed by the individual parts of the system versus how much information is processed by all of the parts put together. And it's to do with how much the second thing exceeds the first thing, and in a sense, and that is how much consciousness there is there. And in a way, it actually has some synergies as long as you don't think that it's necessarily measuring this property of the universe, which you can put a number on. But it has some synergies with global workspace theory, because they're both distinguishing between global holistic things versus local things, and the consciousness is in the kind of global holistic processing versus the local local processing in both those theories. So there's a kind of there's some intuitions that they have in common, I think.
Interesting, and it also reminds me a little bit about what Chalmers speaks about. So he thinks that it strongly emerges from certain types of information processing. And the processing must represent causal structures as well, so it's not an appeal to panpsychism per se.
Right.
Although with all of the things that you've just spoken about, would they work in another universe? I mean, I guess what I'm saying is it just the physical and the information processing, or in a different universe might it not emerge in the same way?
Yeah, which depends what you mean by a different universe, I guess. What do you mean by a different universe?
Well, if the laws of nature were different.
Yeah. Okay. So if the laws of physics were different, well, I guess I dislike isms. I'm an anti-ismist, or rather, I'd say I'm not an ismist.
Yeah.
But if I were to, but I do sort of subscribe broadly to functionalism, I suppose. So I guess.
Yeah.
But what do I mean by that? I mean, what I mean is. I really dislike saying that I subscribe to these isms. So what I really mean by that is that I imagine that a system that is organized in a particular way functionally in terms of its information processing, and if that system is embodied in the broadest sense, and meets lots of other prerequisites, then it's likely to behave in a way where I'm going to naturally use the word conscious to describe it, perhaps, and where I'm going to treat it like a fellow conscious creature. So ultimately, I think it's about the kind of organization you need to give rise to the behavior you need to talk about the thing in a certain way.
My question to that, because I posed this question to Chalmers last week, because he's also a functionalist, and I agree with the degree of functionalism describing intelligence, but less so with consciousness. There's not a Turing test for consciousness, for example. But the thing is with functionalism, we're at risk of doing what you said people do with large language models, which is anthropomorphizing them, because these functions are intelligible to us, and then our conception of intelligence becomes somewhat observer relative.
Yes. I mean, what I observe a relative. So,
as in you understand these functions, so it's conscious to you, but not to someone else.
So in all of these cases, I mean, I think it's about the words that we use in our language to talk about the things. So if there's someone else is someone just like us, right? Then we have to, and if we want to use the words in different ways, so the large language models are a great case in point, right? So suddenly we're arriving at a point where somebody can describe something as conscious, and others can say that's rubbish. That's not true at all. And so we've arrived at a point where these philosophically problematic words, which we use in ordinary life quite harmlessly, and we all are in agreement about how we use the word. Like, so if somebody says, Fred has drank so much last night, he passed out, he was completely unconscious, or if an anaesthetist says, yes, the patient is now unconscious, they can't feel pain, or if you say, I just wasn't aware, I didn't see the cyclist, and that's why I hit them, I'm really, it's tragic, but I just didn't see them. And then, so you're saying I wasn't aware of it, so that didn't influence my action. So there we're using the terms in ways that we all understand. But now we're getting to a point where suddenly these words or these concepts are being used, we don't have we don't have agreement about how to use these words, right? Because there are these exotic edge cases.
Yes.
So then the question I think that you're getting at is, is there a fact of the matter there, right? And so I'm very tempted to say, the first thing I'm tempted to say is that I don't think there perhaps is a fact of the matter, or certainly I don't want to speak as if there is a fact of the matter, but rather I think we need to arrive at a new consensus about how we use these words. So that might mean that we extend the words, we break them apart, like I was suggesting earlier. Maybe we need to separate out awareness of the world from self-awareness, from integration, cognitive integration, from the capacity for suffering, because suddenly we have things where they don't all come as a package, and we need to kind of be a bit more nuanced in the way that we use these words. We need to use them in new ways. But then there's a kind of transition period, because we don't, we're all arguing about how to use these words all of a sudden, because we've got weird edge cases. So there's going to be a time when it'll take a time for language to settle back down again. So there's a kind of there's a kind of observer relativeness to this for a bit, if you like, but then there's a kind of consensus needs to emerge, right?
There's so many things to explore there. I mean, I would love it if this Platonic idea of concepts were possible. And
I think what Platonic idea?
Well, because what we're talking about here is reductionism, and the parable of the blind man and the elephant comes in quite nicely. So, as Chomsky said, complex phenomenon beyond our cognitive horizon, and as much as we don't want to, we use functions derived from behavior to have some common understanding of this thing.
But I wasn't being reductionist, was I? Do you think I was being reductionist?
Well, no. So you said that the language game converges, and in some cases we will arrive on a common definition. But you can bring in Hofstadter as well.
Well, not a common definition, but a common usage, right? Okay. So we'll come to use the words, with agreement, right? So that's what and the reason why I would the reason I would balk at using the word reductionist is because, and that's why I'm a bit resistant to functionalism as well, to any kind of ism, is because I just think that maybe the way things are organized when you take them apart, so brains, right? When you examine them on the inside, like animal brains, you might look at how an octopus's brain works, and that might inform whether you think that it experiences pain or not. or we might break apart, an AI of the system of the future, right? And we may break it apart, and we may look at its functional organization, and that all is grist to the mill of how our language might change, right? So I'm not subscribing to the fact that consciousness is this or this is that with some big metaphysical capital letters on the "is," right? That's really important. The functional organization of the things, which when we study it and look at it, is all just becomes part of the conversation that eventually is going to help us to settle on maybe new ways of talking about these things.
I think we agree with each other. I think the difference is, so with the parable of the blind men and the elephant, all of the men around the elephant saw something which was part of the truth. Yeah. And I think that's what we're describing with the function. So we can all agree on what perception means or what action means. But the thing is, there will be many other functions that will represent a different slice of that cognitive phenomenon.
Yeah, I agree. And I think that's very much true with consciousness, actually, because lots of people come in with kind of like new ideas and new theories. I mean, Anil Seth, for example. Have you had Anil on your?
Not yet. Being You, right?
So Anil's written this great book called Being You. Yeah. And Anil brings in a whole kind of new set of ideas. He's particularly interested in the sort of top-down effects on perception, top-down effects on perception. So then he brings in this kind of top-down influence in perception as a big part of things. And then there's Graziano has written this book using this about his attention schema theory of consciousness, and there's a whole set of interesting ideas there. And I think you're absolutely right. I think there's aspects of all of these things that all feed into the way brains and animals work, and all of them feed into the why they behave the way they do and why we use those words when we use those words, conscious and aware and so on.
Fascinating. We'll get to your article in a second, but as someone who has such a diverse and interesting background, who is allowed to ask these philosophical questions? It reminds me Thomas Metcalfe was talking about the arguments between neuroscientists and philosophers about freedom of the will. Yeah. Who gets to decide?
Yeah. Well, what a great question. So why should I have any right to speak about any of these things at all? Because I have no formal training in philosophy. So who gets to I guess there are two things, right? I guess there's in that kind of discussion between the neuroscientists and the philosophers. So there you're not talking about the everyday conversation that we're all having as humanity, or as English speakers or as Chinese speakers, about how we use these words. So there it's much more kind of confined to two different schools or disciplines within academia. So there, I do think that that people who work in AI and in neuroscience probably at least should be a bit familiar with the philosophical debates. And you mentioned Descartes earlier on, and you're familiar with just that basic kind of sort of stuff which is like philosophy 101, for which people should at least be aware of Descartes' arguments, and then Chalmers and the different kind of perspectives on those sorts of things before they pitch in. At least I mean, you wouldn't pitch into neuroscience just by making up some stuff about brains if you hadn't read an introduction to neuroscience. And so I think that the scientists need to they need to kind of have a pass to enter the conversation, which is to have got through philosophy 101.
Yeah, it's so true. We have the same thing with the ethics folks, actually, because we have a lot of fields of expertise, and engineers should learn more about ethics.
Yeah, absolutely.
But when they do have an opinion about ethics, quite often it
can sometimes be a bit naive, and at least you should be familiar with the kind of. But that's an interesting and a difficult area in itself, because of course, as a scientist, it's important that you take responsibility as a scientist, and that you take some ethical responsibility. But at the same time, you've only got so much time to become an expert. So it's difficult to at the same time take ethical responsibility. And yet, even though perhaps you haven't got the time to kind of read up and become an expert on the relevant ethics. So, I mean, perhaps everybody again should get to the entry level, ethics 101, and indeed many courses teach, ethics these days, many kind of science and computer science. It's part of, of any degree these days. So that's a good step, I think.
Yeah, there's an interesting analogy between the functionalism that we were speaking about in consciousness. I mean, even in our own research domain, we have the function of ethics, and we have linguists, and we have all sorts of different people.
Yeah.
And that is the blind men and the elephant. And, I tend to believe that even though the views from these diverse folks are inconsistent, diversity is very important.
Oh, incredibly important. Intellectual diversity is, every kind of diversity is important, and intellectual diversity is immensely important. And having these conversations, these interdisciplinary conversations, is absolutely, essential. So at least if people are talking to each other, that's a really, really positive thing, I think.
Fantastic. Now, we invited Chalmers on our podcast after Ilya Sutskever's tweet. And by the way, Chalmers took a very functionalist approach to talking about consciousness. But I guess after that tweet, everyone in the community started thinking about and talking about consciousness. So maybe let's just start from that tweet. How did you find it?
Sure. Yeah. Okay. So the tweet was, so Ilya Sutskever said it may be that today's large language models are slightly conscious. And then I replied, tweeted back in the same sense that maybe a large field of wheat is slightly pasta. And that in fact was actually I've got a fair number of Twitter followers, but that was the most engaged tweet I've ever sent out, it got celebrity likes. Hannah Fried retweeted it, and it was my kind of comment, but that does kind of summarize sort of what I think about what he said at that point. But then I, after tweeting my flippant response, I was violating all my own Twitter rules in just sending back a flippant response, because I generally don't do that. I would rather kind of be professional and engage professionally, and so I thought it was very important to follow that on with a little explanation of why I thought that it wasn't really appropriate to speak about today's large language models in those terms.
Yeah.
And for me, the number one thing is to do with embodiment. So as I see it, embodiment is a kind of prerequisite for us being able to use use words like consciousness and so on, in the way that we do in the normal everyday way of talking. So it's only in the presence of something that inhabits our world. And by inhabits, I don't mean just has a physical, like a computer is obviously a physical thing in our world, but inhabits our world means that, walks around in air, or swims or jumps or flies or whatever, but is inhabits the same world as us and interacts with it and interacts with the objects in it and with other creatures like ourselves. So that, to my mind, so in that paper, Conscious Exotica, I think I use this phrase, channeling Wittgenstein, that only in the context of something that exhibits purposeful behavior do we speak of consciousness. And the way that's phrased, there is kind of, as I said, I was sort of trying to channel Wittgenstein's style of saying things, because you notice that he's saying that he's making, what he's saying is actually he's talking about the way we use the word. So he's not making a metaphysical claim. This is essential. He's saying that these are the circumstances under which we use this word. So we use this word in the context of fellow creatures, basically. And so that's kind of the starting point. So a large, and of course we talk to people on the telephone and over the internet and so on, and we don't, we may not, we can't see them or anything. So we still know that there is, or we assume, we've always been able to assume up to this point that there is a fellow creature at the other end, and that's the kind of grounding for kind of thinking that way and using that word. Now that is absent in large language models. So large language models do not inhabit the world that we do. Now, I mean, we have to caveat that because, of course, it's possible to embed a large language model we always do, embed it in a larger system. It might be a very simple embedding. It might be just a chatbot, or it might be much more complicated. Like it might be part of a system that enables a robot to kind of move around and interact with the world and take instructions and so on. So there was some great work from Google with their Palm Saycan robot, for example, where there's this embedded large language model. So there you're kind of moving in a direction where maybe where these words, the prerequisites, for well, actually, I want to be careful what I say here. Sorry, because it's so easy to say something that's can be misinterpreted, right?
Yes.
But we can imagine that requirement being met for not it doesn't mean it wouldn't be a sufficient condition for using those words, but at least you'd meet the necessary conditions, right? But the large language models by themselves they're not even candidates.
I agree, and there's so many things we can do here because we can talk about embodiment in general. I mean, as I understand it, Rodney Brooks kind of started the phenomenon of thinking about a representationalist view of artificial intelligence, or an embodied
rejecting a representation.
So Rodney Brooks thought that we should use the world as its own best representation, which is absolutely fascinating. And then you maybe you might be thinking about the embodiment view in a similar style of Wittgenstein. So it's a matter of complexity, and it's also a matter of encapsulation, which is fascinating. But also, just to quote your paper, you said, although the language model component of Saycan provides natural language descriptions of low-level actions, it doesn't take into account what the environment actually affords the robot. So there's this whole affordance thing as well. So I mean, how do you think about embodiment?
So the way I see it is that the one exemplar we have as of the end of 2022 of something that we really can describe as intelligent, as generally intelligent, is the biological brain. Biological brains of humans, but also of other animals. And the biological brain, at its very kind of nature, is it's there to help a creature to move around in the world, to move. Right? It's there to move, help to guide a creature and help it move, in order to help it survive and reproduce. That's what brains are for. So that's what, from an evolutionary point of view, they developed in order to help a creature to move. And they are they're the bit that comes between the sensory input and the motor output. And insofar as you can cleanly divide these things, which maybe you can't, but I mean, so that's their purpose, is to intervene in the sensory motor loop in a way that benefits the organism, and everything else is built on top of that. So the capacity to recognize objects in our environment and categorize them, and the ability to kind of manipulate objects in the environment, pick them up, and so on, and all of that is there, initially to help the organism to survive, and that's what brains are there for. And then when it comes to the ability to work out how the world works, and to do things like figure out how to gain access to some item of food that's difficult to get hold of, then all kinds of cognitive capabilities might be required to understand how you get inside a shell or something to get at the fruit inside it, or something like that. Complex cognitive abilities. And then evolution has developed a lot of more and more complex cognition until we get to language, and we need to interact with each other, because that's all very much a part of it, the social side of it, and then language is part of that. So as I see it, it's all built on top of this fundamental fact of the embodiment of the animal and the organism. So that's in the biological case. So that's sort of our starting point.
Yeah.
So and so that seems to me to be the most natural way to understand the very nature of intelligence.
Could I frame it? I think I didn't frame it very well. I mean, Melanie Mitchell recently had a paper out talking about the 4 misconceptions in AI, and one of them, of course, citing Drew McDermott, was the wishful mnemonics and the anthropomorphization, which you've basically spoken about. But her fourth one was about embodiment, and she spoke about this in her book as well. And she said that one of the misconceptions of AI is that people have this notion of a pure intelligence, something which works in isolation from the environment. And you're talking about social embeddedness and embodiment. And I guess my point with the complexity argument is I'm saying that the brain itself doesn't actually do everything. It kind of works as part of a bigger system.
Oh, I see what you mean. Yes. Okay. Yeah. So there's, so of course there's, I mean, I noticed in one of your previous interviews with Andrew Lampinen, you mentioned the 3 E's framework, or 4 E's.
4 E's, yes.
4 E's these days. And of course that's very much part of it is the idea that, there's the extended mind. We use the environment, as a kind of memory, for example. For we deposit things in the environment. Writing, is an example, and so on. And then there's people talk about morphological computation. I'm sure you're familiar with that. So,
no, what's that?
Well, so that's the idea that the very shape of our bodies, could. So sometimes the aspects of intelligence are actually outsourced into the physical shape of your bodies. So where you might think about designing a robot, where you put a lot of work into the control aspect of it, so that it can kind of walk in this very carefully engineered ways that it's always permanently stable. Or alternatively, you can make a body that is naturally sort of stable, or maybe naturally unstable. And what you do is you kind of rely on the combination of the physics of it constantly falling with a control system that constantly restores balance. So that's I mean, this is very much a Brooks type perspective, and people picked up on Brooks's ideas and extended them in this sort of way. So I think that's a very natural way of thinking.
But in a way that this gets to the complexity argument, because I guess what I'm saying is that life is much more brittle than anyone realizes. You were just pointed to some sources of brittleness that most people never would have thought of, which is fascinating.
So I think there's a very important relationship between embodiment and language, and this also brings us back to Wittgenstein as well. So for us as humans, language is inherently an embodied phenomenon. It's something that is it's a social practice. It's something that is a phenomenon that occurs in the context of other language users who inhabit the same world as we do, and where we have kind of like joint activities. We're triangulating on the same world, and we're acting on the same world together, and that's what we're talking about when we use language. So there's this. That's an inherently kind of Wittgensteinian view of language. I mean, and I think it's deeply, profoundly correct view of language. That's what language is there for us, is so that we can talk about the same things together, so that our collective activity is organized to some extent thanks to language. So I think that's a really important perspective on language, this Wittgensteinian perspective, and embodiment is at the heart of it. Embodiment and inhabiting the same world as our other language users, and that's the way we learn language. We learn language by being around other language users, like our parents and carers and peers, and that's again a very important aspect of the nature of human language. Now, large language models, they learn language in a very different way indeed. They do not inhabit the same world as us. They do not kind of sense the world in the way that we do. They don't learn language from other language users, from their peers in the way that we do, but rather we know how large language models work. They're trained on a very, very large corpus of textual data. So an enormous corpus of textual data, so bigger than any human is likely to encounter. By the time they become a proficient language user at a young age. And what they're trained to do is not to kind of engage in activities with other language users, but to predict what the next token is going to be. Which is a very, very different sort of thing. So they're very, very different sorts of things, and the role of embodiment is really, really important in this difference, I think.
Yes, absolutely. When I spoke with Andrew Lampinen, he's really, really interested in the grounding problems. I mean, would you mind just speaking about that a little bit before we go into your paper?
Yeah, absolutely. Yeah. So, of course, this goes back to a great paper by Stephen Harned back in, I think, 1999 or 1998. So,
Yeah, the one and only.
Yeah, the one and only on the symbol grounding problem, it was called, and he does argue broadly that symbols in AI systems, the kinds of AI systems he was thinking about at the time were kind of sort of expert systems, say, or something like that, and the symbols there are not grounded; they're provided by the human programmers, and they're just sort of typed in. Whereas for us, the words we use, those symbols are grounded in our activity in the world, so that when we use the word dog, that's because we've seen dogs and we've talked about dogs with other people who've also seen dogs, and we've seen dogs in lots of different circumstances, and we've also seen cats and dog bowls and bones and many other things that all kind of contextualize that. But all of that is kind of grounded in the real world, in our perception of the things in question. So that's what sort of is meant by grounding, or that at least that's the original meaning of the word grounding from Stephen Harned's paper.
Yeah.
And I think that's a really, really important concept because in an important sense, large language models, the symbols that are used in large language models, are not really grounded in that kind of way. Now, I should be absolutely clear that large language models are immensely powerful and immensely useful, and so that but it's interesting that to what extent the lack of grounding here that we have in today's large language models, might affect how good they are. So they are prone to kind of hallucinating and confabulating, and if you look at multimodal language models that maybe we'll talk about an image that you present to them, then you can have a very interesting conversation, but sometimes they'll go off piste and start talking about things that are not in the image at all, and as if they are, and that's sort of because due to a kind of I would say a lack of grounding. So the words are not kind of grounded in the images in quite the way that we would like. So it's an important topic of research, I think.
Yes, indeed. And although some people do believe there's this magical word called emergence, and possibly some emergent symbol grounding might be possible. Maybe should we just put that to bed before we introduce your
sure.
paper?
Well, I mean, emergence I think is a really important concept, and I think we do see a tremendous amount of very powerful emergence, I think, in today's large language models. So even though they're basically trained to do next word prediction. Mm-hmm. Or I mean, to be clear, I suppose I should have made this maybe a bit clearer in the paper. But of course, it's not always next word prediction, because the different models learn to actually predict what's in the middle of a sequence rather than kind of. But generally, they're interested in let's take the next word prediction case as canonical. Yes. So they're trained to do next word prediction. Now the astonishing thing is, as I think GPT-3 showed us, is that just that capability, if it's sufficiently powerful, can be used to do all sorts of extraordinary things. Because if you provide a prompt that describes some kind of complicated thing, situation, like I need to tile my floor, and my floor is shaped like an L, and it's 20 meters long and 3 meters. Well, you start to describe this thing, and each tile is 20 centimeters square. How many tiles will I need? And some large language model will come back and tell you, you need 426 tiles, whatever, and it's correct, right? Yeah. Well, this is astonishing because it was only trained to do next word prediction. And so there's a kind of emergent capability there. Now, there's a sense, of course, in which it still is just doing next word prediction, because in the vast and immensely complex distribution of tokens in human text that's out there, then the correct answer is actually the thing that's most likely to come up. And but it's got to discover a mechanism for producing that, right? And so that is where the emergence comes in. And I think that these capacities are astonishing. The fact that it can discover mechanisms, emergently that will do that sort of thing.
Yes, and maybe I shouldn't have used the word magic with emergence. I'm a huge fan of emergence. And as you say, the decode is trained to predict the next token, or the denoising autoencoders to let's say, fill in the gaps in the middle. And I guess there are different ways of thinking about emergence. So there's weak emergence, which might be thought as computational irreducibility, or a surprising macroscopic change, or strong emergence when it's not directly deducible from truths in the lower level domain. Lots of things.
Yeah, the different senses of it, yeah.
Exactly. But I guess my point is that, remarkably, it's trained on something quite trivial.
So all of this is about convention, right? All of this is about what is a good way to use words, right? So I don't think I'm not making metaphysical claims about these things. So it's all about when is it appropriate to use words, to use certain words, and because when this becomes problematic is when they're philosophically difficult words like believes and thinks and so on. Now, when it comes to reasoning, so I do think it's not unreasonable to use that term to describe what some of these models do today, and that's partly because of the content neutrality of reasoning. So a lot of the argument or a lot of the discussion in the paper comes back to this sort of whole embodiment thing, really, and I'm saying, well, in the kind of like ordinary way we use the word believes, well, it gets complicated because we do use the word believes in this intentional stance way to talk about ordinary everyday things. We say, oh, my car clock thinks that it's British summertime, because but then you'd say, somebody says to you, what you mean your car clock can think? And you say, no, obviously I didn't mean that it can think. It's just a turn of phrase, But when we get to these large language models, and we start to use the words like thinks and believes and so on, because they're so powerful, it starts to get a bit ambiguous. And some people will say, well, actually, I really did mean that it can think or that it believes. So I'm interested in this when things get difficult in this respect, and.
Could you tease apart though? So you resist anthropomorphic language in terms of belief, knowledge, understanding, self, or even consciousness.
Yeah.
But less so with reasoning. And my intuition is that reasoning rather depends on those things that I just said before.
Well, I think it doesn't, because but perhaps this is just maybe in a kind of formal logic sense, because logic is content neutral. So if I tell you that
could you just explain what you mean by that?
Okay.
Yeah.
So Lewis Carroll has all these wonderful kind of like nonsense syllogisms, right? Where he says, oh, if all elephants like custard, and Jonathan is an elephant, then Jonathan likes custard, and all kinds of things like that, and it's all sort of nonsense. And he has this big complicated ones. And similarly, I could tell you that all Sprogforths are plingy, and Juliet is a Sprogforth, therefore Juliet is splingy, right? And I've no idea what any of those things mean, but it's because for the pure form of the reasoning, you don't have to know what they mean. It's just about the logic. So in that sense, it just in the way that a theorem prover can do logic, then so can a large language model do logic. So in that sense, I think it is reasonable to use the word reasoning in that logical sense in the context of large language models. So I don't think that's a problem. Of course, we may think that they do it badly or they do it well, or that's a whole other thing, right? But at least the word is potentially applicable, right?
Yes.
Now, belief, I think at the moment is a different kettle of fish, because to really hold a belief, it's not content neutral, right? So if I believe, to use the example in my paper, if I believe that Burundi is to the south of Rwanda, well, whether that is the case or not, it does depend upon facts that are out there in the world. And then to really have a belief, at least you've got to be able to somehow try and kind of
justify
those facts, or at least, and you've got to be at least built in such a way that you can, interact with the external world and do that sort of thing, right? And verify that something is true or false, or do an experiment, or or ask someone, or you've got to go outside yourself, right? We go outside of ourselves, and in order to establish whether a belief is true or not. And so you've got to at least be capable of doing that. Whereas large language models, the bare bones large language model, is not capable of doing that at all, right? Now, you can embed it in a larger system. This is a really important distinction that I try and make over and again in the paper. I talk about the bare bones large language model. So you can take whenever a large language model is used, it's not the bare bones large language model, which just does sequence prediction, but it's embedded in a larger system. When we embed it in a larger system, well, that larger system maybe could consult Wikipedia. Maybe it could be part of a robot that goes and investigates the world. So that's a whole other thing. But then you have to look at each case in point and ask yourself whether whether we really want to use that word in anger, as in its full sense, rather than just in the intentional stance sense of a kind of figure of speech. So in the case of like chatbots, for example, today's chatbots, not really appropriate, I would say. We're not using the word in the way that in the full-blown sense that we use it when we talk about each other.
Fascinating. Okay, well, let's get on to intentional stance. So you said that it's a useful way of thinking about artificial intelligence, allowing us to view computer programs as intelligent agents, even though they may lack the same kind of understanding as a human. And you cited the case of Bob and Bot. The word no was used differently in the two cases. In the word of Bob, it was used in the traditional sense. For Bot, it was used in the metaphorical sense. So it kind of like, it's this distinguishing what it means to know, for humans and for machines.
So I think it's useful to think about something like Wikipedia. So we might ask the question, does Wikipedia know that Argentina has won the 2022 World Cup? And just immediately after the event, it probably doesn't, it's not recorded in Wikipedia, and somebody might say, Wikipedia doesn't know yet that Argentina have won. And so when we use a word like that, nobody's going to kind of say to somebody who uses that word, hey, I don't think you should use the word knows there, and you should be a bit more sort of sensible. I mean, it's fine to kind of use, I think, these kinds of words in this ordinary everyday sense, and we do that all the time. And that's sort of particularly in the case of computers, that's adopting what Dan Dennett calls the intentional stance. So we're interpreting something as having beliefs, desires, and intentions, because it's a kind of convenient shorthand, and especially if you've got something that's a bit more complicated, like say your car's sat nav or something, or your sat nav on your phone, then it sort of makes sense to use those words. It is a convenient shorthand, and it helps us to kind of talk about them, right, and without getting overly complicated and without knowing the underlying mechanisms. But there's an important sense in which we don't mean it literally. So in the case of Wikipedia, you couldn't go up to Wikipedia and pat it on the shoulder and say, "Hey, Argentina have won," and say, "No way, right? I want a beer," and all the things that go with us as humans actually knowing things, and it's just a turn of phrase. Now things get sort of interesting with large language models and with large language model based systems and the kinds of things that we're starting to see in the world, because we're starting to get into this kind of blurry territory where we're blurring between the intentional stance and meaning it literally. And this is where we need to be really, really kind of careful, I think. So at what point do things shade over into where it's legitimate to use that word literally in the context of something that we've built? I don't think we're at that point yet, and we need to be very careful about using the word as if we were using it literally. That's the sort of anthropomorphization, because the problem is that we can then impute capacities to the thing and or even empathy, say, that just isn't there.
Yes, I suppose we could tease apart knowledge, so a justified true belief, from knows, because knows that it brings all this baggage of intentionality and agency and anthropomorphization.
But you had Chomsky. You've had Chomsky on.
Well, I could tell you a story about that. I mean, the recording messed up. So when we were interviewing him, we were only getting bits and pieces, and we had to deep fake him. We had to regenerate the interview.
Oh, really?
And he was saying in the entire interview how much he hated deep learning and how useless it was. And then we used deep learning to rescue his interview, and he gave us his...
literally did that?
Yeah.
Did you tell him?
Yeah, and he gave us his permission to publish it.
That is wonderful.
So it's quite ironic. But no, he always says it's wonderful for engineering, but not a contribution to science.
Yes, sure, yeah.
Yeah, he said, I like bulldozers too. They're good for clearing the snow, but they're not a contribution to science.
So who else have you had? I mean, you've had a lot of people on. I listened to Andrew's one, by the way. It's Andrew Lampinen.
Yes, he's great.
So he's great. So Andrew's somebody I do work with quite closely.
Oh, wonderful.
So it was interesting listening to him, because Andrew had quite a big influence on this paper, by the way.
Oh, okay.
And I mean, but I think I might have had a bit of influence on him as well, to listening to.
I think so.
Because that interview was just after he read my paper and gave me lots of comments, and we had a lot of discussion about it. And that interview, looking at the recording date, was sort of just after this, and it's interesting. I mean, he was very circumspect in some of the things he said. Yeah, it was very interesting because he. I think the influence has maybe gone both ways.
Yes,
which is nice. I don't know. I mean, I can't be sure of that, but
I think there's a huge similarity. Yeah, I was thinking that actually just when you were speaking.
But it's funny because we've spent a lot of time arguing with each other about it, and I often feel like we're coming from very different perspectives on this. But in fact, I think there's convergence really.
What are your areas of disagreement?
Well, you see, I would have thought that Andrew would have been more on the side of, we can do things without embodiment and without grounding, or to kind of take grounding in a more liberal sense, because some people would talk about grounding. So they say, well, the large language models, they are grounded.
Prompt engineering is the process of using prompt prefixes to allow LLMs to understand better. So the context and the purpose of a conversation in order to generate more appropriate responses. What do you think is going on with prompt engineering?
Yeah, well, yeah. So you let slip a phrase there. It's the process of allowing the models to understand better is what you. But of course, I don't think
guilty as charged.
I don't think that's the right way of characterizing it as at all.
Yes.
I mean, I think the whole thing of prompt engineering is utterly fascinating, and it's something that's entered our world as AI researchers very prominently just in the last 2 years, and it's amazing. Of course, we have prompt engineering in the context of large language models. We also have prompt engineering in the context of the generative image models as well, like DALL-E and so on, and that's really fascinating as well. How by engineering the prompt to be just the right sort of thing, you can coax the model into doing something which you might not otherwise do. And it's a great example of how alien these things are, because if you were giving a human being the same instructions, then you wouldn't necessarily do quite what you do with either an LLM or an image model in order to get it to do the thing that you want it to do. You have to kind of get into the zone with these models and figure out kind of what strange incantations are going to make it do the things that you want it to do. Now, I think an interesting thing is that we may be looking at a moment, a very short moment in the history of the field where prompt engineering is relevant, because if language models become good enough, then we're not going to need to talk to them in this weird way, or engineer the prompt to get them to do what we want them to do. It's going to be a lot easier. But anyway, so maybe that'll be the case. I mean, that makes a lot of sense that will be the case as they get better. But at the moment, you can use a strange incantation like think in steps, and suddenly the large language model will be much more effective on reasoning problems than it was if you didn't use the incantation think in steps. So that's really fascinating. So what's going on there? Well, I mean, I think what's going on there is that, we have to again bear in mind that what the model is really trained to do is next word prediction. But we have to remember that it's doing next word prediction in this unimaginably complex distribution. So, and it's not just, we have to remember that it's not just the distribution of what a single human would, the distribution of the sequence of words that a single human will come out with, but of all the sort of text of millions of humans, on the internet, plus actually a load of other stuff like code and things, which we don't come out with in ordinary everyday language. Well, people do at DeepMind a bit, but that's DeepMind. So it's this unimaginably complex distribution, and so I think what's happening with prompt engineering is that you're sort of you're kind of channeling it into some portion of the distribution. So you're queuing it up, with a prompt, and you're this kind of context is putting it into some portion of this distribution, and that is what's going to enable it to do something different than it would have done if you had a different set of words, and that would have put it in a different part of the distribution. So you're kind of finding the bit of this unimaginably complex distribution. You're finding the bit of it that you want to then concentrate on.
Yeah, so intuitively, I agree, because I think there's two ways of looking at this. So I agree with you that they are statistical language models. I'm also a fan of the spline theory of neural networks, which is this idea that you just kind of tessellate the ambient space into these little affine polyhedra, and it's a little bit like a locality-sensitive hashing table. But it's quite a simple way of looking at it, because you were talking about emergence before, and emergence is all about this paradigmatic surprise, a bit like the mind-body dualism, if you like. There's something that happens up here which is paradigmatically completely different to what happens down there. So on the one hand, we're kind of saying, oh, they're just simple interpolators or statistical models. But on the other hand, they really are doing something remarkable up here. So which is it?
Which is it? Well, I mean, it's both, right? So if we want to understand these models in a more scientific way, which we surely do, even if we're not engineering them in an old-fashioned sense of engineering them, but rather they kind of emerge from the learning process, but we still want to reverse engineer them to try and get as great as comprehensive a scientific understanding of these things as possible. So we want to understand it at all these levels, right? Of course, the foundation of that understanding is that we need to understand the actual mechanisms that we've programmed in there, right? So that's essential. You want to, if you want to really understand these things, you've got to understand transformer architectures, the different kinds of transformer architectures that you've got, what happens when you use kind of different parameter settings, whether it's sparse or dense, whether it's a decoder only architecture, or how you're doing the tokenization, how you're doing the embedding. I mean, all of these things are essential to understanding, and that's all absolutely at the engineering level. So we want to understand all of that. But then we can do a whole load of reverse engineering at another level, and do the sort of thing that the people at Anthropic AI have done, for example, with these induction heads and understanding in terms of transformers in terms of residual streams and induction heads, which I think is fabulous work. So that kind of thing is looking. It's still at quite a low level, but it's kind of the next level up, and explaining a little bit about how these things work, and work along those lines, I think, is like really essential. And then the more complex these things are, the more we need to kind of ascend these levels of understanding, and I hope that we can. But I mean, there's no one that is the right one. It's you want to understand that things at all levels.
Yeah, different levels of description. You said something before which really interested me. You said when the language models get good enough, maybe we won't need the prompts anymore. And I'd love to explore that duality, because it's a similar duality to how we talk about embodiment. You can think of the language model being embodied in the prompt in some sense. So maybe we'll never get rid of the prompt. But just to think about these prompts, I think about them as a new type of program interpreter. And there are some remarkable examples of scratchpad and chain of thought, and even algorithmic prompting for getting insane extrapolative performance on lots of standard reasoning tasks.
Yeah.
And these models are not Turing machines. They're finite state automata, so there are limits to what we can do. But I guess what I'm saying is the prompt seems like it's not going away anytime soon.
Yeah, so I think that I don't think the prompt is going to go away, but I think that who knows, right? But I think that prompt engineering as a whole kind of thing in itself, may not be, people talk about that as being a kind of a whole new job description, prompt engineer, and that as a whole new job description, I'm not quite sure how long exactly that will last, because prompting may be just interacting with a thing in a much more natural language way, in the way we would with another person, right? So I don't have to kind of think of some peculiar incantation in order to get my colleagues to kind of help me on something, or to to cook a meal together with somebody. We just use our natural kind of forms of communication. I mean, of course, it does involve discussion and negotiation, but it's just the same as we use with other humans, right? So it may be that rather than it being a peculiar thing in itself, with all these funny phrases that just work for peculiar, eccentric reasons, that it may be much more natural.
Amazing. Professor Shanahan, thank you so much for joining us today.
Thank you very much indeed, and thank you for the invitation. It's been lots of fun.
Absolute honour. Absolute honour. Right.